Solving absolute value equations. So let's start with a basic one. At its very basic, well, not very basic, but pretty close to it. We want to solve the absolute value of 2x minus 5 is equal to 9. Now, when we're solving absolute value equations, there's a few things we want to do. Step number one is to isolate the absolute value on one side of the equation, which is already done here. Okay, so step one of the first thing you want to do, right? Number one, isolate the absolute value expression. I'm just going to say abs-val expression. Okay, and then what we're going to do is we're going to look at two different cases, right? So we're going to have to solve two different cases. Number two, solve two cases. Because really what we're looking at here is if 2x minus 5 is equal to 9, that will be one of the solutions, right? If this expression here is equal to 9, that's a solution. But if this expression here is equal to negative 9, that's also a solution. Because if what's in here is equal to negative 9, when we take the absolute value, it's going to become positive 9. Okay, so I'm going to show you how it is, how we're going to look at these two cases. Okay? So first off, let's revert to yesterday a little bit and write it as a piecewise function. So remember yesterday we were writing the absolute value function as a piecewise function? So we would say the absolute value of 2x minus 5 is equal to, well, it's just equal to 2x minus 5 if the x value is greater than or equal to 5 halves. Now, this part of it's not really terrifically important, but you know, we can still state it. If x is greater than or equal to 5 halves. Right, that's just basically solving that for 0. Right, when is 2x minus 5 equal to 0? When x is equal to 2.5, right, or 5 halves. Any value of x above 5 halves will give us a positive value, okay? Which means that we just have the 2x minus 5 expression, since any value of x greater than 5 halves or equal to will give us 0 or a greater number. And it's equal to the negative of 2x minus 5 if x is less than 5 halves. Okay? Now for us, the important part really is these two things here, right? It's these two equations. That's the important part. We're going to solve those two equations. Okay, so let's start off. We're going to do case 1. Whoops. Case 1. Okay, so case 1 is that 2x minus 5 is equal to 9. Which solves pretty easily, right? So 2x is equal to 14. And x is equal to 7. Now, since case 1 matches up with this, and it says that case 1 is true if x is greater than or equal to 5 halves, or 2.5, and this is greater than or equal to 5 halves. So then this should be a solution. But the thing is, despite this, whether we do it or not, we're going to check all of our solutions, right? So we're going to verify every answer we come up with to make sure that it's true. So first, we've done case 1. Now we're going to do case 2. I'll just do that over here. Case 2 is that this expression, so the negative of 2x minus 5 is equal to 9. Now you got a couple of choices at this point, right? We can distribute that negative through the brackets, but that's too much work, right? And since the 9 is here all by itself, we can just say, well, let's multiply both sides by negative 1, turning the left side positive and turning the right side negative. Okay, that make sense? Yeah. Okay, so now we're going to solve this. 2x minus 5 is negative 9, right? That makes sense, right? You think about it. If 2x minus 5, if this thing here is equal to negative 9, when we take the absolute value, we're going to make it positive 9, so it'll work. So 2x, we're going to add 5 to both sides, is negative 4, and x is negative 2. which matches with the condition for case 2, which is that x has to be less than 2.5, right? And negative 2 certainly is less than 2.5. Okay? So, any questions to this point? No. Okay, no. It's very simple, kind of linear. Really, well, they're both linear. You're just solving 2 linear equations, right? 2 lines. Okay, now what we want to do is we want to verify. Okay, and we need to verify both solutions. So I'm going to say verify. And we're going to do a left side, right side verify. So the left side is equal to the absolute value of 2x minus 5. And the right side is equal to 9. And when we do the verification, we go back to the original equation, right? Back to the original problem. We don't use the cases. Right? We go back to the original problem. We say, okay, so verify it, let's say this, for x equals 7. Okay, so it's the absolute value of 2 times 7 minus 5, which is the absolute value of 14 minus 5, which is the absolute value of 9, which is 9. So that checks. Okay, that verifies, right, if the 7. Now, you're asking, well, so on a test, do I have to show the verification? And we're going to say, well, if you don't show it for a solution which doesn't verify, then for sure you're going to lose marks, right? Because you'll be leaving something and saying, hey, look, this is a solution, when in reality it isn't. Now, in this case, both of these actually will verify. So let's just say, how long does it take to verify, really, right? Like, it's not that long to process. So verify for x equals negative 2. Okay, and we're going to do the same thing. We're going to keep a short right-hand side, right? That's equal to 9. The left side is equal to the absolute value of 2x minus 5. So 2, now let's replace the x with a negative 2, right? Minus 5. Which gives us the absolute value of negative 9, which is 9, and that checks. So both of those answers verify, right? Okay, so any questions on this?
So when you're verifying, you shouldn't use
Don't use the cases. No.
Okay.
Always go back to the original. Because the thing is, if you made a mistake in your cases, or if you made a mistake in rearrange, like this is too simple, really. There shouldn't be any mistakes here, right? But if we get an expression where there's an absolute value on one side, and then there's like 3x minus 1 on the other side, then we could make mistakes like moving stuff over. And so we want to always go back to the original to verify. Now, we can also take a look at this graphically. Okay. So to verify this graph, or to solve graphically, or to verify, now most of the times, right, 99.9% of the time we are asking you to solve, to algebraically determine the solution. So you're doing it algebraically. You can, however, check by graphing, right? So if I want to say, hey, well, so are those correct? So where do we get absolute value from? It's out of the math menu, right? So we got math, and over to num. And number 1 is ABS, so I can hit 1 or enter. And whoops, somehow I jumped up. So let's go into here. So I want the absolute value of, now on the 83, it'll show as ABS open parenthesis, right? On the 84 with the fancy stuff, it'll actually show that absolute value symbols. So 2x minus 5. That's the left side, and the right side is 9. So I'm going to graph this as 9, and I'm going to hit graph. And it'll graph standard window. And now we do a second calc intersect, right? And we are interested in the x coordinates of the point of intersection. Since we know the y coordinates have to be 9, right? Y2 equals 9. So we're just going to do a second calc intersect. And I'm going to move till I'm close to the intersection. I like to do it this way and hit enter 3 times. 1, 2, 3. So we've got negative 2, right? X is negative 2. And that's one of our solutions, right? So, this gives you a chance to verify. All right, what's going on? Second calc. Okay, there we go. Gives you a chance to verify graphically what you are seeing algebraically. I'm finding the intersection of the two curves.
What?
Y2 equals 9. Y2 equals 9. Right, so left side graphed as Y1, right side graphed as Y2. Find the intersection. Okay, actually I'll show you a different method. We'll do another verification. So we're going to hit enter 3 times. First curve, second curve, and guess. And there it is, 7. Okay, so that's verification, right? Which really for this you didn't need to know. 2 times 7 is 14, minus 5 is 9. The absolute value of 9 is 9. 2 times negative 2 is negative 4, minus 5 is negative 9. Whose absolute value is 9. Okay, but figured I should show that. Okay, any questions on this first example? Very straightforward. Okay, we're going to do a bunch more.
The same thing.
All class. Is there homework on this?
Yeah, of course.
So if we get it, should we just go on the textbook and
Knock yourselves out.
So,
I'll knock myself out? It'll be fun.
So the absolute value of x minus 2 is equal to 3x plus 1.
Oh no.
Okay, so we're upping the ante on this one a little bit. It's not just a number that's on the right-hand side, right? So now we have the absolute value really of one line, because x minus 2 is a line, is equal to some other line, right? 3x plus 1 is another line, as opposed to looking for just the number 9, right? Which, although that is a line, y equals 9, but it's a boring line. Okay, 3x plus 1 is less boring. Okay, so let's start this out. Okay, so the absolute value is isolated, so we're good there, right? I mean, if that was like a plus 5, then I would move that over. Okay, but we're not. It's not. We're good there. Let's do our definition of absolute value. This will help anyway. Whoops. This will help for doing piecewise functions if you're asked to express as a piecewise function. So the absolute value of x minus 2 is just x minus 2 if x is greater than or equal to 2. Right? Any value of x greater than or equal to 2 gives this a positive value, so it's positive. And it's the negative of x minus 2 if x is less than 2. No, well, if x is less than 2, let's say 1. 1 minus 2 is negative 1, so I have to take the negative of that to make it positive.
the first one, like if x is greater than 2, it's not if x is greater than negative 2.
No, 2. It's got to be greater than positive 2. What makes this 0? The value of x of 2 makes this 0.
Oh, okay.
Right? Like if we graphed x minus 2, that's y equals x minus 2, right? And so that's your 0 occurs at 2.
Okay.
Okay? So that's the dividing line, right? Because now to do the absolute value of that, we take this portion and we reflect it like so.
Right.
Okay? And that's your absolute value graph, which I'm now going to clear. Okay, so that was yesterday's stuff, right? How to graph the absolute value graphs and all that good stuff. So now we're just algebraically, we're going to solve this. We're going to say, where do these two lines intersect, right? One of which is that absolute value, and the other one of which is just the line 3x plus 1. And we'll verify it graphically as well. So we'll do this and then we'll graph it just so we get a look. And on a test before you do this, you might want to graph it and just say, well, what does it look like? How many solutions are there? What should I be expecting? Okay, because it doesn't take long to graph, but realize that you have to solve it algebraically, right? Okay, so we're kind of going to ignore this for a moment, right? We're just going to say there's two cases. So case 1 is that x minus 2 is equal to 3x plus 1. Okay, so case 1 is just taking the first case, the positive value. Okay, so the two cases that we're always solving are, it's the positive of whatever's in the absolute value signs, and it's the negative of whatever's in there. That's always the two cases, right? They never vary. So it's isolate the absolute value, take it as a positive, set it equal to the right side and solve. Take it as a negative, set it to the right side and solve. Okay, what do we get? I'm going to move this over. We're going to get 2x is equal to negative 3. So x is negative 3 halves. Excuse me, negative 3 halves, right? I'll let you look at it. You figure it out. Say, yeah, okay. Right? Again, if you have any questions, this is the chance to ask, right? You're not sitting at home watching a video. You're in the process of making one. Okay, so what I do is I move this x over here, becomes 2x. I move the positive 1 over there, becomes negative 3. But I like my x's on the left, so I just write it the other way around. Okay? So really, I guess what you would see in here is you get negative 3 is equal to 2x. Right? That'll make you all happy. Oh, thank God, everything's in the right place now. Okay? And then I reverse them.
Yeah, but if you subtract 3x from both sides, wouldn't it be negative 2x?
No, I'm subtracting x from both sides.
But like, if we did it the reverse.
Oh, if I did the reverse, then I would get negative 2x is equal to 3. There's only one answer, right? It's how you get there really is. Yes? No? How do you want me to do it? I'll redo it.
Okay,
if you
so
want.
negative 3 equals 2x.
Yeah. So, okay, my thinking is this. I have a 3x here, I have a smaller x here, so I would rather subtract the smaller from the larger because it'll come out as positive.
Yeah.
Okay? If I had a negative x somewhere, I'd move it to the other side so I would add it. Okay, so I move this over here, it becomes 2x. The negative 2, I got a 1, I have to subtract 1 from both sides, gives me negative 3. Okay, and then I just write it this way and then solve. Okay, that's case 1, right? Done. Okay, case 1. Case 2. The negative of x minus 2 is equal to 3x plus 1. Now, at this point, you have two choices as to what to do with the negative. I'm thinking we might as well just distribute it in on the left-hand side, right? Like in the other case, it was a 9, and it was easy to make that 9 a negative. Right? Say, okay, negative 9. But here, okay, let's just go with negative x plus 2 is 3x plus 1. I'll try not to mess you up. Okay, I'll do it this way. We'll add x to both sides and subtract 1 from both sides, right? So 2 minus 1 is 1. And add x to both sides gives me 4x. Okay, so you're going to add x to both sides, and you're going to subtract 1 from both sides. Okay, and then what am I going to say? What's x equal to? 1/4. Now, I kind of ignored the cases, and I did that for a reason. This case 1, this case here, case 1 says x has to be greater than or equal to 2, but this isn't. So probably this won't check. But I would rather just verify it than worry about the cases. Because if I mess the cases up and then just reject a solution, I might be rejecting an actual solution. So, we're going to kind of, we'll write this in when we can, but we won't really let it guide us from that point on. If you look in the book, they would have said, on a similar situation, they would have said, well, this isn't a solution then. Okay? Now, we're going to check that for ourselves. Okay, so we're going to verify. For x equals negative 3 over 2, we're going to do a left side, right side. So the right side is 3x plus 1. Okay, and the left side is the absolute value of x minus 2. Okay, and that's the original equation. We always verify in the original equation, not in anything subsequent, right? Because if we make a mistake in subsequent stuff, we'll carry that mistake through. Okay, so this is the absolute value of negative 3/2 minus 2. So if I just write that down as negative 7/2, will anybody go, oh, wow, where did negative 7/2 come from? Sure. Okay, common denominator, 2 is 4 over 2, right? So this is the absolute value of negative 7/2. Which is equal to 7 over 2. Okay? Again, at any point, if you've got a question, you got to ask. Right? Otherwise, I'm going to assume that you're okay with what's going on. Okay, right side. It's 3 times negative 3/2 plus 1, which is negative 9 over 2 plus 2 over 2. Right? Just changing the 1 to 2 over 2. it's still 1, right? 2 divided by 2. And this is negative 7 halves. And we put an x. Say, no, that does not verify. Okay? Now, this happens often in an absolute value expression, right? Where when you go to verify, the absolute value side has to be positive, right? It's going to work out positive. The other side is going to give you the same value, right? But it'll be negative. And so they don't verify, right? Because, I mean, we solved this. We solved an equation. We got a nice number here, right? And it says basically both sides are going to be, that's negative 7 halves, and so is that. But when you take the absolute value of it, this now becomes positive. This is negative. That's not a solution. So it's called extraneous, right? That's the word for the day. This is an extraneous solution, right? And it's introduced by the study of the two cases. Okay? When we start working with radical equations and you square both sides to get rid of the radical, you again will introduce extraneous solutions. So you really have to check whenever you're checking, whenever you're solving an equation, you really have to check. Okay, so let's check this. Verify for x equals 1/4. The left side is the absolute value of x minus 2. The right side is 3x plus 1. So let's do this side first. We got 3 times 1/4 plus 1, which is 3/4 plus 4/4, or 7/4. Okay, well, let's look at that. 100. Agree with the veracity of the statement.
Or are you still verifying case 1?
No, that's case 1, which didn't verify.
And then isn't case 2 negative x minus 2?
Case 2 is this one, the negative of x minus 2.
Right,
Which
so why don't you have that on the left side? Is
No. We always verify in the original equation. Okay, the original equation, one that you've got under number 2, if you call this number 2. We go to the original equation, right? Because the problem is, what if we make a mistake in our case? You know, then we will have solved it, we'll have a legitimate solution for the wrong problem, but it won't be a solution to the original. So we always verify back in the original. Okay, so we go the absolute value of 1/4 minus, I'm going to call this 8/4, right? Because 2 is 8/4. Which is the absolute value of negative 7/4, which is 7/4. And so that one checks. Question again. Now it's question, yes, you may go.
Are we doing this like every class now?
I don't know, what do you guys want to do?
No, not this.
Okay, so next. Let's take a look at this graphically. So I got to go here to turn this on. Okay, so we're going to y equals, I've got the absolute value of x minus 2, so I'm just going to edit this. Delete x minus, change that to a 2. And then in the next, I'm going to clear this, and we've got 3x plus 1. 3x plus 1. And we hit graph. So there's x minus 2, there's 3x plus 1. There's the one solution, right? Which we will agree without verifying it. We will agree that's 1/4 for the next value, right? I mean, we could do it, but do you want me to do it?
No, please.
Yeah, you say, well, yeah, I think it pretty much has to be because the 1/4 is what you solved in there. Okay, but here you can see that there is only one solution to this, right? That the other solution was introduced because of this process of solving the two cases. Okay, so if you're verifying, and again, I mean, on a test, you might want to just plug that in at the beginning, you look at it and say, okay, there's going to be one solution. But you still need to show the verification. You need to reject this solution. You can't just say extraneous for no reason. Okay, so reasons that I will allow are, you can use the case here. So you can say, since this value, for case 1, since the x value has to be greater than or equal to 2, you know what? But no, let's just say, you're going to have to do it algebraically and reject it. Make life easy on you. Okay, so you just do an algebraic verification, reject one solution, accept the other solution. Life is good. Next one. This actually, this will be a short one. Short. This is short. Okay. Certainly. It's not the bathroom, so at least a different place. What's the first step in solving an absolute value equation? Isolate the absolute value. So what do we end up with? Equals? Okay, anybody want to make a comment on that? Along the lines of, but the absolute value is always positive, so how can it be equal to a negative? And the answer is? The empty set, there's no solution, whatever you want to write, right? No solution. And you can write it at this point, right? Since the left-hand side is always positive, right? The absolute value of something, so no solution, since the left-hand side is always positive. Okay, and then you can stop there, right? There's no further work to show. You don't have to do your cases. Because if you do your cases, you will get two values of x that will make each case true, neither of which will verify in the end, right? Because you can't get a -4 out of this, which is what you need, right? Because I got to take something and add 5 to it and get 1. That something has to be -4. That's what we isolated it.
What happens if you don't realize that and you keep going?
You'll get two solutions, and when you go to verify them, they won't work. No, you'll get two solutions, and when you go to verify them, they won't work, and you'll say this has no solution, and ultimately you've wasted 10 minutes, but you'll get it. Sorry?
If it's x minus 4, will there be, like, if the s of x is positive?
If this had been a -5 to make that a +6, yeah. But
What about, like, if there's an x on the other side?
oh,
Like, does that have to be positive?
no.
It can
Well-
be negative x to work?
Oh.
So what if it's -4x?
Well, if x were negative something, that might work, right? Like, so if that was -4x, there would be a solution.
There would?
Yeah, because if x were a negative value, this would turn positive, right? Like, so no matter what that expression became, so if we ended up with like -4x, then if x was negative, this side would become positive, and I'm sure we could find a value. And if it were -4 minus 7x, right? Then again, same deal, right? As long as x were negative, this would turn positive. It would override the 4, giving you a positive value. There'd be a solution. Okay, but it's not,
So
right?
it
It's
doesn't
just,
matter, like, if the x is positive or negative?
if you see an x here, you need to solve it.
Okay.
Okay, make life easy. If it's just equal to a negative number, you could say there is no possibility of solution since the left side is always positive and the right side is always negative. Can't solve.
Do you ever mess with stuff in the absolute value thing?
No.
So you have to leave that in the brackets of absolute value?
Yeah, what we do is we do the two cases. We just say we take it by itself and we take it with a negative in front. We stick it in brackets. What? Right, and then we.
What does LHS say?
What does what?
LHS.
Left hand side. See, good. Making interaction now. Okay, next one. Fear not. There's only two more. Well, I want to show you all different kinds of examples, right? So you're able to tackle. So in this one, we're going to have a quadratic in here. Well, not in here. We'll have this, but we'll have it equal to a quadratic. So x squared. Okay. What do you want to do? Do you want to graph this first, just to sort of say, hey, what does it look like?
Sure.
Who wants, or who wants to, or just solve it algebraically?
Solve it.
Okay, let's just solve it. Let's save graphing for verifications and for multiple choice or numeric response questions, right? If you see numeric response rounding to the nearest hundredths or whatever, you graph it. If you see a multiple choice that you graph it. Like when I'm doing the Pure 30 diplomas or the 30-1 diploma, it's all machine scored. I don't do anything algebraically that I can do graphically, right? But when you see exact value, you have to do it algebraically, right? When you see the answers written in the form a plus or minus root b over c, and what's the value of a plus b plus c, you have to do that algebraically, right? Your calculator cannot give you an answer. Okay, step 1, isolate the absolute value, already is. Okay, step 2, let's just take a look at the absolute value. So again, and this is just good review for yesterday, right? It's x minus 5 if, what's the condition? X is greater than or equal to 5. And it's the negative of x minus 5 if x is less than 5. I'm going to write these. I'm pretty much going to ignore them when I do this kind of work, right? Because I want to solve and verify every solution and accept or reject it based on its own merits, not on, because, what if I get that wrong? What if I wrote -5 there and I start rejecting actual solutions because I made a mistake here? Okay, I don't want to do that. Yeah.
Why is it greater to or equal to the 5 and the next one's only less than 5?
You could say less than or equal to on both, because the equal to will be where it's 0.
So, okay, because I was really, because there's only the top one that's always equal to. So
Yeah.
you don't test, I can put it whenever.
You could put it on both of them, it would be equally true.
I can put on either of them.
You could put it on one or both, but not neither.
Oh.
The reason you can't put it on neither is 0 is a possible solution,
Okay.
possible value. So we're just lumping the zeros in with the positives. I'm just saying, well, it's positive. When x is greater than or equal to 5, this expression will be greater than or equal to 0 or positive. But 0, is 0 positive or negative?
Positive.
It's neither. 0 is the Switzerland of numbers. It's neutral, right? It's there to divide the positives from the negatives, but it takes no sign. Okay? So, okay, we got to do 2 cases. Case 1. So case 1 is this. X minus 5 is equal to x squared minus 8x plus 15. And I'm going to write out case 2 at the same time, but we'll solve them separately. Okay? I'm just writing them both down because I can scroll up and give myself some room to solve. Okay, so you got the idea of the 2 cases, right? So the whole idea behind this, we're doing like 6 examples, is you isolate the absolute value, get it by itself on the left-hand side, and then you do the 2 cases, which is the absolute value, just remove the absolute value signs and just take the expression as it is, and then put a negative and brackets around it. So convert the absolute value into brackets and stick a negative in front. That's your second case. Okay, so let's scroll down and solve. So this is just a quadratic. I'm just going to go x squared. I'm going to subtract x from both sides, minus 9x. I'm going to add 5 to both sides, plus 20, and that'll be equal to 0, right?
Doesn't x equal 5? Or x equal 5, negative 5?
No, it equals 4 or 5. We're not there yet.
Yeah.
Oh, you made one side equal to 0.
Yeah. So since it's an equation, right, I got to make one. So in order to solve a quadratic equation, you have to set it equal to 0. Now, if life is not good at this point, this won't factor. Right? This does. But there's an example in the book where they give you one of these where it doesn't factor, and then you have to use the quadratic formula. Okay? So remember, there are solutions. Just, this does factor, though, right? What are the factors?
5 and 4.
Yeah, so x minus 5, x minus 4 equals 0. Do we stop there?
Yes.
Yeah, only certain people. Okay, so x equals 5 or x equals 4. I'm going to ignore the case thing that we put up there saying it has to be greater than or equal to 5, which sort of says you should probably reject the 4. Right? We're just going to check the 4. We'll verify it separately on its own merits.
So why do we do that the other person ignore it?
If I see this on a test, can I just be like, the 4 isn't worth it?
No. And the reason, because I want to verify. What if 4 is a solution?
Well, it's not.
Well, we don't know that. We know that maybe here. What if it ends up being a solution here?
Yeah.
Okay. So yeah, we'll verify it in a sec. So now on this one, I'm just going to distribute this negative through the brackets there, right? I don't want to turn this side, and then because it's just too much work. So, but it's your choice, right? Negative x plus 5 is x squared minus 8x plus 15. Okay, so this time I'm going to add x to both sides, right? So I'll get the x squared. I'm going to add x, that'll give me minus 7x. And I'm going to subtract 5, which will give me plus 10, and that's equal to 0. Okay? Everybody good? Made the left side negative, right? We distributed the negative sign through the parentheses, making the left side change signs, moved everything to one side, going for the positive x squared, right? I mean, never move an x squared and make it negative. Because then, you don't want to do that. Okay, so this factors, right? X minus 2, x minus 5 equals 0. And don't forget this, right? Don't start dropping off the equals zeros. You know, oh, I'm just factoring in that. No, I mean, you're solving, it's an expression, you know. It needs to be there. It's part of what you're communicating mathematically. Hey, this is equal to 0. It's what allows you to solve it. Okay, so we got x equals 2, and we got x equals 5. So twice we have 5. Now here's why. Why don't you reject? Well, this is case 2, and it says if x is less than 5, then I should, it says x has to be less than 5. This isn't. Happens to be equals to, right? Now, that's why it's best just not to reject. Let's just check them all. Okay.
So you make it do that?
Where?
You're saying at the top. I don't know.
No, you know what? I'll live without this, but if I ask you to write it as a piecewise function, you have to write this. Okay? But if you're solving one of these, you don't have to write it. I'm writing it just because if I write it every time, then you can't say, well, sometimes you do and sometimes you don't. And so, you know what? I'm going to write it every time. Except for the next example where I won't write it. There's a reason why. But there can't be variations on the rule. You'll see when we do the next example why I won't write it. But let's just verify this. So verify x equals 5. The left side is equal to, so I got to look at my original. It's the absolute value of x minus 5. That's not going to take much space, right? Which is the absolute value of 5 minus 5, which is 0. Okay? I'm not going to write the absolute value of 0. The right side is x squared minus 8x plus 15. So it's 5 squared minus 8 times 5 plus 15, which is 25 minus 40 plus 15, which is 0. So that checks. Okay, both sides are 0. That's fine. Don't reject, right? So we say, oh, but it's 0, so I need to reject it. No, you don't. The left side and the right side are the same. You need to accept that. Okay, let's verify x equals 4, which we expect probably won't, but we're still going to show it. Don't worry, we'll give you plenty of time on this test to, spend a minute verifying if you have to spend, or, 2 minutes verifying or whatever. Just practice it now so that when it comes time to do it on the test, you won't be sitting there going, how do I verify? Okay, so it's the absolute value of 4 minus 5, which is the absolute value of negative 1, which is 1. And this is 4 squared minus 8 times 4 plus 6, 15. 16 minus 32 plus 15, which is negative 1, so that does not check. Not verified. And one more, which is x equals 2. Which in this case we expect to verify, right? Okay, I'm just going with positive 3. Okay, I mean, verifications need to have some detail, but 2 minus 5 is negative 3, and the absolute value of that is 3. Okay, so, you know, and the right side, x squared minus 8x plus 15. But if you want to see more detail, just ask. You know. So it's 4 minus 16 plus 15, which is 19 minus 16, which is 3. So that checks, right? Which we expected based on our case analysis. Okay? Which we're not going to rely on. We'll just let it guide us and say, probably this one will check.
And then do you still have to verify the next, the case 2, x equals 5?
Again, I already verified
so
x is
it
5.
doesn't sort of matter.
So lucky us, right? We had to verify 3, but okay. Verifications don't take long, right? I mean, you know, and again, you know, you can graph this. So we could solve this graphically. I'm not going to, but you know, left side, you know, equation 1 is the absolute value of x minus 5. Equation 2 is x squared minus 8x plus 15. Find the x coordinates of the point of intersection, right? There's another way to verify graphically, which is you could put it all on one side. You could do the absolute value of x minus 5 minus this, and then look for the zeros. But you'll get really weird looking stuff. Like if you graph this and this, you'll know what it's going to look like, right? I know I get a V shape and I know I get a parabola, and I'm just looking for where they, you know, where they cross each other, where they intersect. If you choose to graph it as one equation, then you just get something that sort of does this and then drops down through, you know, it just doesn't look anything like either of those.
So now do you say that like the x mod?
Oh, yeah, let's give the solution. So let's write out the solution. So solution, x equals 5 or x equals 2. You could write it as, okay, you can put it in brace brackets, not parentheses, right? Not round brackets. You can't make an ordered pair out of it. It's not an ordered pair. It's a set of 2 numbers. Okay? And you should always state a solution for each of these separately, right? Because that allows you to reject stuff. You know, and then just say, okay, my solution set is x equals 2, x equals 5, or it's the set 2 comma 5, or whatever. Right? So state it explicitly, because that's what I'm going to look for. Right? I want to see an answer. Okay, one more. Yeah, I can go back. One more. Let's try and keep this under an hour. 43 minutes in. Okay, last one. So we have the absolute value of a quadratic. So we know what that looks like, right? Usually looks like a little hump in the middle, and then so 2 things going on here with a little hump in the middle. Because quadratics usually dip below, they do this, and then we reflect that part up above. And we've got 3, which is just a vertical line, right? At y equals 3. Okay, the absolute value is isolated. We'll do our case stuff. So the absolute value of x squared plus x plus 9 equals x squared plus x plus 9. Now, that doesn't factor. I don't know the zeros of it. I could graph it and kind of get an idea of where the zeros are. I could solve it with the quadratic formula and get where the zeros are, but I'm not going to. So, not listed. Due to lack of effort. Good word.
So what do you list the 0?
Okay, on a for real, give me the piecewise function. If I gave you this, you would have to use the quadratic formula, find the zeros, and then state it. Okay, in solving this algebraically, we're just going to say, you know what? I'm going to solve it. I'm going to verify every answer, just as we have till now anyways, and I'll reject ones that aren't. but I won't be able to look at something and say, oh, yeah, that's case 1 and the value should be greater than or equal to 5, and it isn't, probably this one won't work. Okay, I'm just not going to say that.
So on a test, we can't say this.
You can say it. You can say this. Okay, not if I ask you, but I won't. I won't ask you to express it as a piecewise function unless the numbers are reasonably easy to find, like the zeros. Okay. You know, like a half and 3, it's factorable, you'll find the zeros. But this is like, you know, what's the 0? What do we got? We got -1 plus b squared minus 4ac.
There is none. Because it's positive.
Oh, sorry. This should be -9.
Oh.
My bad. Yeah, there would be no zeros the way it's written, would there?
Sharp as a tack, this one.
Yeah. Sharp as a Sharpie. Okay, it still doesn't factor, right? So I could find the zeros, but okay, there, nice and clean. Okay, so 2 cases, right? We do the x squared plus x, so case 1. X squared plus x minus 9 equals 3. Gives me x squared plus x minus 6 equals 0. Gives me x plus 3, x minus 2 equals 0. Now anytime you factor, you check. X squared minus 2x plus 3x will be plus 1x minus 6. Okay? Because you want to make sure, if you reverse these, then you know, it all goes to heck from there. Right? Which means x equals -3 or x equals +2. Now, both of those could be solutions, or neither of them, or one of them. We won't know until we verify. We've got no clue here, you know, because we don't know where, you know, the zeros are, not easily. But it's okay, because we're just going to verify. So,
It's, oh, right.
okay, I could turn everything on the left side negative, but that would be really a waste.
If you subtract a 3 from that side, it would become
You subtract.
-12.
Oh, darn. Okay, well, let's fix that. You couldn't have said that, like, I don't know, how long ago? Yeah, you know, I mean, at home I would have eventually found that, maybe not. You know, or there'd be corrections in the video. All right, so what do we got? X plus 4, x minus 3. Okay, there, thank you, yes. Mistakes. Why are you sitting here? You gotta earn your money.
What?
Wait, no, that's it. I'm making errors on purpose from now on. No, I'm not. Trust me, I will make errors. I make them at home all the time. It's just then at some point I get to the, what? That doesn't work, and then you just don't see that 10 minutes, right? And I got to scrub it back and redo it. So. Either I try and verify it graphically, and then I go, well, that's not the graph. Like I didn't get those answers. Why is this not working? Okay. Now here's the thing, though, right? When I went to verify, probably neither of those may have worked when I verified in the original. Okay, because I actually ended up solving a different equation. Okay, let's see if I can get this right. Oh, this will be x squared plus x minus 6, right? All right, well, good. We already solved that one. So x plus 3, x minus 2. Assuming I did this right, it would have been, well, wait a sec, why do I have the same expression for, well, it's at that point that I recognized I would have made a mistake, right? Like, why are both of these the same? They can't both be the same. One of them has a negative, and, yes.
Wait, sir, how did you choose if you were going to distribute that negative sign through it, or you just added on the -3?
Oh. If I make this negative, then I'm going to have to move them all over to the other side or remake it positive because I don't want to factor.
So you just move it over to the other side?
Yeah, I just say, let's multiply both sides by -1. Turn this expression positive, make that a -3. Easy. It's your choice. It doesn't matter. It will solve the same regardless. Okay? This is, to me, is just less work.
Okay.
Okay, if I make this
Well,
negative,
you didn't multiply each side by negative one, you switched it over, didn't you? 'Cause if you.
in essence, I multiplied both sides by negative 1.
No, or she would have had negative.
That made this positive, made this negative.
Okay.
How do you want to think about it? Okay, I divided both sides by negative 1. Okay. All right, so we have 4 things to verify. So let's make some room for verification. Yeah, we have 4 possible answers. Maybe all 4 work. Do you want to graph it so we know how many we got that actually work?
Sure.
Okay, so why don't we graph this? Again, you don't have to, right? But okay, and actually, I'll show you both ways of graphing it. Why not? We got time. Okay, so I have the absolute value of x squared. So I need to square that x. How do I square that? Okay, x squared plus x minus 9 plus x minus 9. And the other expression is just 3. So I can go here and go over and then just delete. Okay, and so I can graph that. And we can see, we do in fact actually have 4 solutions. Right? So all 4 of these solutions will verify. Okay, do you need me to show you the verification? You need to show me the verification. Do I need to show you?
When you show me the y, you would have to verify.
Okay, hang on, I got 2 names.
Just put in that graph.
On a test, we would say you verify all 4 of them.
Yes.
Okay, so what did you put in the graph again? You did absolute value of x squared plus x plus 9.
Okay, so here's what I put in the graph, right? So y1 is the left-hand side, and y2 is 3. Now, you could also graph y1 as the absolute value.
Like that.
Well, I can't help you. Okay, hang on. I could also graph this and clear y2.
Yeah. Mine
Wait,
worked.
what?
Okay.
That makes no sense.
All right. What I did for this is I graphed the absolute value of x squared plus x minus 9, and then subtracted the 3. So I turned the equation from this to this. So now I can just look for the zeros. Instead of looking for the 3's, I can look for
So
the
that's what you
zeros.
put in the graph now?
Yeah, so now if you look, by the scale here, we've got 1, 2, 3, 4. We've got -4, -3, +2, +3. -4, -3, +2, +3. Okay, so they all do, in fact, work. They all verify.
Yo, Yanni, come have a look
Okay.
at this. So there's
1 sec. Do you want me to verify them? No. Okay, you should. I won't. And now you can work on your homework. So.
It's 54 minutes.
And here's all 4 verifications. So then we write in our solution.
No, we did it.